Hello family, it's Mrs. Vore here to teach you evaluating logs. Today our focus is going to be on evaluating logs using technology. So in our case we are going to use DESMOS as our calculator to evaluate logs. I taught some of you guys how to use our calculator, so some of you guys know how to evaluate logs using our calculator. Today we're going to talk about evaluating logs using our Chromebooks, and in order to do that we're going to go to DESMOS. Before we get into that, let's just briefly review what we've been talking about in terms of logs. So in our last lesson you guys learned how to add and subtract logs. I changed our note sheets from our note packet so that you have a page, the top part is on adding and subtracting logs, and now the bottom part is on evaluating logs. If you're watching this and you have the packet, that's totally fine. Just keep the packet and turn that in for your points. But if you were able to print this, then you can use the back of this paper if you would like to follow along with these notes that I'm about to do with you. So what we know how to do so far with logs is the following. If I give you a log base 4 of 64, if I want to evaluate that, what I have to do is ask myself, what exponent would I need to use in order to get 64? And in this case, the exponent that we would need to use is 3. Or we could do something like log base 2 of 16, same thing. What exponent would I need to put on 2 in order to get 16? Well, this one would be 4. So both of these are an example of evaluating a log. So if I turn to the next page though, and I look at this very first problem here, evaluate log of 6.29. Well, there's a couple of issues here. Number one, where's my base? So log of 6.29, on this back side, we had log base 4 of 64, log base 2 of 16. So issue number one, there is no base number. Issue number two, we have a decimal. So regardless of what my base is, I could say my base was 4. Even if I had a base, it would be extremely difficult for me in my head to be able to answer the question, 4 needs what exponent to be 6.29? There is an exponent that exists, but it's not something that we can calculate in our heads. This is where technology comes in. So let's address the first issue. We have log of 6.29. And the question is, what is the base? There is no base number written there. Well, it actually has a base number. This is called the common log or the standard log. Let me give you an example of something that's similar to this that you guys know of. If I asked you, what is the square root of 64? Hopefully you guys are all saying in your heads, 8. 8 times 8 is 64. Well, I could also ask you for the cube root of 64. So this is square root, 8 times 8. This is cube root. The cube root of 64 is 4 because it's 4 times 4 times 4. I could do the fourth root of 64. Can I? Let's find out. I don't think it has one. So let's try I know it has a sixth root. The sixth root of 64 is 2. 2 times 2 times 2 times 2 times 2 times 2. So if I'm taking the sixth root of a number, that means what number did I have to multiply 6 times in order to get 64? Here, if I'm taking a cube root, I'm asking what number did I multiply together 3 times to get 64? So in this case, there is no index number. My answer is 8. I was asking how many times, or sorry, what number do I need to multiply together 2 times to get 64? This is your common root. It's so common that we don't put the 2 on. Whenever we see a root symbol, we know that that's the square root, so 4. Or root 25 is 5. What we often don't think of is the fact that these all have an index. This is called an index number, but the index is 2. We never write it on, though, because we just know that this is the standard root. It is also kind of like saying 1x is the same as x. We hardly ever write the 1x on because we all just know that this is just 1x. So where is this all leading to? Why am I talking about all these different things? Because the logs have something similar. The common log is log base 10. So if you ever see just log written out, and if I flip back to this page and look at the examples, you can see that the first two just say log. That means that their base is really 10. The common logarithm is log base 10. So if it's ever a base 10, they just write log. They do not write the base. There is one that is similar, and it is the natural logarithm, and this is log base e. So e is a special number that goes on forever. So if I wanted to know the decimals for e, I could plug it into my calculator. E is like pi. He's a really special number that goes on forever and never repeats. Goes on forever and never repeats. So E represents natural growth. It is the number that we use to represent how things grow in real life, the rate at which things grow in real life. I shouldn't say the rate, but it best models natural growth. That is why if we have a log base E, E is this special number, we call it the natural logarithm. So if you have a base 10, it's just called log. If you have a base E, and E is this special number that's like pi, we call it the natural log. So I may highlight those two things just for my reference or put a box around them or something. So ln has a base E, log has a base 10. Because these are so common, because these two are so common, we actually have calculator buttons for those. So if you've learned this in class with me, you know that we use this log button, that's kitty corner from the 4. The natural log button is like next to the 4. Why did I say kitty corner from the 4 when it's like right by the 7? So the log is right by the 7. The natural log is right by the 4. Because we'll probably be using our Chromebooks a lot in class, I am going to show you how to do this on the DESMOS calculator. So I am going to just type in to my address bar, DESMOS.com. At the very top, I'm going to go to Math Tools, and I'm going to click on Scientific Calculator. Now, I normally have you guys in the graphing calculator. I want you in the scientific calculator. It's the second option. Look, there's that cube root that we just talked about. Now, when you're evaluating a log, so our first one was log 6.29, all we have to type in is log 6.29, and here's your answer right here, 0.7966. This 7 right here tells you to round up. So we want to write 4 decimals after, or 4 digits after the decimal. So that means we use this 5th digit to decide to round up or not. So 5 and above, you give it a shove, you round up. 4 and below, you just let the numbers go and you keep what you have. So log 6.26 is 7965. 7965. So on my paper right here, I'm going to write 0.7965. Okay, B is log 33. So if you hit enter here, it'll keep track of the things you've plugged in. I'm just going to hit log 33. This one is 1.5185. So this 5th number here, 1 is too low, so we just let all these digits go, and we keep these 4 numbers. So back on our paper, we're writing down 1.5185. Okay, so same with the natural log. Natural log is so common that we can just type in ln. We just hit ln. It's not in, it's ln 7. Okay, this one is 1.9459. This 5th digit that's a 1 is not big enough to round up. So 19459. You pause this video, you do D without me writing the digits down, and then check your answer against mine. Really, pause please. Do it and then check in. Actually, you're doing log 40. Hopefully you didn't pause, because then you'd probably be like, what you doing, teacher? Okay, this was 19459. So now you guys are doing natural log 40. So this is where you should pause. Okay, hopefully you paused so that you actually had a shot at this. I would do 3688. 36889. So 36889. Okay, E. Well, shoot. Letter E requires us to have a base number. So you have 2 options here. The long way is the following, and it is in this box right here. This box is telling you that you can evaluate any logarithm with a base if you turn it into a fraction following this model. So you take the log of x and put it in the top, you take the log of the base, put it in the bottom, and then all you have to do is type into DESMOS log over log. So I will do that on letter E. What this is telling me is I need to turn this into log 4.6 over log 7. I put the big numbers in the top, so log 4.6, and by big I mean size, like actual size, not value. And then I put the little number in the bottom, log 7, so literally the size of the number. 7, he's little on the paper. I go to DESMOS. To get a fraction, the easiest way is to type a backslash. I'm going to type in log 4.6. I'm going to arrow down log 7, and my answer is 7842. 0.7842. Now, I don't know about you guys, but I don't want to have to do this on all of my problems on the quiz that require that. Because if you look at your quiz, there are 21 problems. Most of them have a base number. So I personally don't really want to have to go through and make a fraction out of all of these. Well, the good news is there's a function in DESMOS that will allow you to do this. So here is how you get that. You're actually going to hit the function button. So you're going to hit function. So let me show you that again. You're usually on this main option. You're going to go to function. And then you are going to look for the log that allows us to do a base. Are you guys seeing it? I am not seeing it. Usually it's just right here, family. Okay, let's go to Math Tools, Graphing Calculator. So I did Math Tools, Graphing Calculator. I'm going to pull up my keyboard. So right down here you have a keyboard. You're going to arrow up on that. And then in this one, you go to functions down here in the bottom right. Holy moly. You scroll down. So I had to scroll all the way down until you see this log A. I'm pausing here because it's never really looked like this on my screen. So I'm worried it's going to look different on your Chromebooks. If it does, so if you go to the Functions tab and it gives you 3 things across the top, you'll hit on Miscellaneous. So whatever yours looks like, click through the different tabs if you have tabs until you find this log base A. And you just type that in. So once I hit that button, if you notice over here on the left, now it's going to allow me to type in a base of 7 and a number 4.6. And now look down here, it gives you your answer. So really, if I would have known that, I would have just had you do everything in this window. So for instance, one of your next problems is log of 8. One of your next problems here is log of 8. Well, you can just do it in the graphing window, log 8. And then right here is your answer. So our answer for letter E was right, whether we used DESMOS or we used what's called the change of base formula. We're getting 7842. For log 8 in DESMOS, we got 9031, so 0.9031. Why, teacher, do you keep doing this? I just wrote it down in the wrong spot. I apologize. Okay, now we can do log base 5 of 45. So you're going to hit functions. You're either going to hit the miscellaneous tab if you have one, or you're going to scroll down until you get log base A. We're going to type in 5, arrow over, 45, and we get an answer of 2.3652. Then last but not least, in DESMOS, I can just type in natural log of 0.3. This time we get a negative, so my last answer is, sorry, my thing's in the way, negative 1.2040. If you struggle with rounding, feel free to just write 4 digits and don't worry about whether you round up or keep it the same. Just write the first 4 digits that you see. So now this is quiz 5.5. If you got this in class, it says 5.4. It's really 5.5. You are going to round everything to 4 decimal places, just like we did here in the notes. So this is the quiz that goes along with it. Feel free to use DESMOS on your calculator on any of these. And as usual, if you have any questions, just send me an email and I will try to get back to you as fast as I can.